In the present video, we are going to show some examples of frequency distribution and histograms in Math Studio using the snippets that have been provided in this YouTube channel. We're going to start with a Math Studio file where we have prepared a matrix of data. We're going to start by inserting the snippets necessary, and these are the SNG information, that means statistics and graphics information, and then the next one is the SNG functions, statistical and graphics functions. With that, we are getting some results already, but the sample is just a matrix, right? A matrix that I call XX. If I want to know how many elements there are in XX, is the function length, 160 elements. You can also say here rows XX, that's 20 rows, and columns 8, so that 8 times 20, 160 elements. The function all stats you make the equal sign right here. It gives you a vector indicating the mean value, the variance, the standard deviation, skewness, kurtosis, first quartile. Second quartile is also known as the median. The third quartile, interquartile range, which is the difference between Q3 and Q1. The minimum and maximum for what's called a plot box. We're going to skip that one in this video. And then the minimum and maximum values of X, and the range, which is the difference between those two. You can also use the function min and max to get the minimum and maximum values. Now we're going to decide how we're going to split our beans for the histogram. And I decided that we're going to start with values of XB minimum, XB maximum that enclose the minimum and maximum values of XX. That means all the data will be contained within the beans. And we're going to select 10 beans. There is a function called frequency T, that means frequency table. It takes as values XX, and then it takes a value of the XB min. We could put it here as the name of the variable that were defined earlier instead of the actual values. And then the number of bins here in bins. And this produces the frequency table. These are the headings that I need to adjust over here. And the K represents the name of each class or each bean, 1 to 10. XBL is the left limit of the bean, 50 to 60, 60 to 70, 70 to 80, and so on. And XM is the midpoint of each bean. F is the frequency count, how many data values are enclosed in that particular bean. The cumulative frequency is equal to the first value. And then you start adding 2 plus 6, 8, 8 plus 11, 19, 19 plus 21, 40, and so on. When you add the total number of data values in this frequency and divide each frequency by that total value, you get the relative frequency. And the cumulative relative frequency could be also thought of as the cumulative frequency divided by the total number until we reach number 1 here. The last vector here represents the outliers, how many values are less than XB minimum, how many values are larger than XB maximum. In this case, we deliberately selected XB minimum and XB maximum to include all data points, and therefore there are no outliers. Now this result right here contains two elements, the big matrix here and this vector. We're going to extract this matrix by typing the name of the variable that I store the frequency table in FT, and I'm going to redefine FT as the first element of FT, so that the matrix here it's stored into FT now. We don't care about this vector anymore. And so I get this frequency distribution. I could drag this down a little bit and copy those headings. Control C, click over here, Control V, move them around to fit the data, to fit the table. I'm going to have to press some. To identify the columns in the table. But what I want to do is I want to extract this vector of F. This is my fifth column, and so I'm going to call it F, is the column F of FT, the number 5, and it gives me this particular vector. Then I'm going to take the vector of bin limits corresponding to the second column. This is the column FT2. And then I'm going to add the last value, which is FT 10 row, third column, and that gives me all the limits from 50 down to 150. I need those two pieces of information, F and X bins, to generate the matrix that's going to give me my bar plot or my histogram, where I put the value of F, the frequencies, and the X bins. Then I calculate the mean and the standard deviation of my data using the functions mean and standard deviation that come with the statistical tools plugin. And then I calculate the area total area under the curve using this function called ATOT that uses F and X bins. And then I create this function, the PDF normal, because I want to plot the bar plot BP and this function to see how nice or how well this normal distribution fits my data. Okay, and so just repeat the type of calculations presented in here, and you can get your own. I have an extra copy of this here. I'm going to delete it and bring this back up here. Repeat these steps and you will be able to obtain your own histograms. Now I want to show you a second option. Instead of enclosing everything, we're going to go for a value of 60 here. That will leave some values in the lower outliers. And you can see there are 2 of them. And then if I change this to 150 instead to 140, for example, it shows that 5 points will be left up above. And then my values here get modified. But the steps, this is a little bit higher, so I need to lower it. There you go. The steps are the same, and the data is accordingly produced, and the values get calculated, and it shows not as good as fitting, particularly in those 2 bars, but it's still symmetric and sort of normally distributed. And so these examples shows how to produce histograms and obtain the frequency table, which were definitions presented in the previous video. And with this, we're going to conclude this particular video.